different ways it can fail. Okay. Bulb, how it can fail. Plug, how it can fail. Cord, how it can fail. Okay. So it can fail in different ways. So all the different ways are noted down. Okay. It can see here he has given you some of the methods in which the different parts can fail. It can fail completely, it can fail partially, it can fail prematurely, or may not function at the allotted time. It can function with a lag. These are the different ways. Okay. So we often call that light bulb illuminates instantly, isn't it? But to tube light, we say that as soon as we switch on the plug, it doesn't illuminate. Okay, maybe now with the advent of technology, we don't have such problem. But then tube light was used for that only. Like a person is called tube light, we say that he understands the joke very late. Okay, after switching on the switching on the tube light, it glows at a with a lag. Okay. So this can also be a failure mode. Okay. So identify the failure modes is complete failure, partial failure, incorrect operation, or uh, intermittent failures. See, we had taken an example. Suppose if we don't take this table lamp as an example, we take maybe the fire alarm as the example, then premature operation. Prematurely, it is giving you alarm, or wrong at wrong time it is giving you alarm, then even that is a failure mode. Okay. So these are the different failure modes. So first step, we have decided, we have jotted down what are the different components of the asset and what are its functions. Second step, what we have done was each component in how many different ways it can fail, we have jotted down that. Okay. Coming to the third step, identify the effects of the failure mode. So for a particular failure mode, what are the effects? So effects we are noting down on three things. Okay, one is on product. So how is the table lamp getting affected? Okay, sometimes few of the failure modes are not hazardous. Okay, it fails but without any problem to the other property and people. Okay, so we have to see the effect of the failure mode. See, that is what the method is known as, right? Failure modes and effects analysis. Effects. So, what is the effect? Okay, the cause is the failure, and what is the effect? How is it affecting the product? How is it affecting the property? How is it affecting the people? Okay, so we have to list all that. Okay, so these effects are best described as seen. We can see here, right? So we have to jot down the effects of the different failure modes. Okay, suppose there is a short, okay, or the installation failure is there. Okay, so what can happen? Okay, so it can be like fuse is blown off, or you can have a shock, or it can be the hazardous, the injury can be hazardous to people. So we have to see the effects on three things. What are the three things? We have to see the effect on product, property, people. Okay, so this is the third step, right? First step, I repeat, first step, we have divided the asset into different components, and we have found out what are the different functions of each of the component. Second step, each of the component and how different ways it can fail, we have to note down that. Then in the third step, we have to find out if such a failure mode happens, what are the effects? How is it affecting the product? How is it affecting the property? How is it affecting the people? Okay, so these are the different uh, effects of the different failure modes of different components. Okay, so we are talking of components, then we are talking of failure modes. In third step, we are talking of the effects. Okay, then step 4, we are not only, see, in step 3 we have talked about effects, but in step 4 we are talking of the severity of the failure mode. How severe is the failure mode? So we are assigning some uh, numbers to it. Okay, see, in research or in management, we say that anything which can't be measured can't be improved. Okay, I repeat, anything can't be measured, can't be improved. I'm not able to see. Someone says that I like you, or uh, so much, right? Can you really measure that? Okay. Uh, if you can't measure that, it's a customer satisfaction. How satisfied is the customer? How effective was something, some method? Okay, so we want to measure that. If it is not measurable, we can't improve that. Feedback also. If feedback can't be measured, we can't improve. See, suppose if we are asking in a very abstract terms, how good was the class? Okay, so you can say that the class was good, very good, not satisfactory, all the different English terms we can use. But then, again, I repeat, anything which can't be measured can't be improved. So if you see the feedback form, you have the Likert scale or any other uh, scale which is being used. Likert scale is basically the 5-point scale. We have strongly disagreed to strongly agree. Okay, so if I say that feedback has to be mentioned on a like Likert scale, okay, so you rate me on a scale, okay, then my performance will be measured in terms of number, right? So here also we are measuring the severity in terms of number. Okay, so you can see here, depending on the FMEA method employed, severity is usually given either a numerical rating or a coded rating. Okay, so you can give severity as 8 means it's very high, 10 means it's hazardous. Okay, even in the pathological lab report, we get some numbers, isn't it? Suppose sugar levels have to be given. Okay, HB1AC is given. Okay, so we have certain numbers. If it is more than 6, it is hazardous. If it is 8, it is panic level, like that, right? So we are here, we are finding out the severity of the failure mode. Okay, severity of the failure mode, and we are trying to give some number. Okay, that number is known as risk priority number. Risk priority number. So based on the priority, we will consider the case. Okay, we will consider the repairing services, right? So first, I repeat 4 steps what we have seen. First step, we have divided the asset into different components, and each of the components function we have noted down. Second was how each of the component will fail. The failure modes were identified. Okay, third step, we have identified the effects of the different failure modes on product, property, and people. Okay, so what are the different effects of when the component fails? Okay, what will happen? Will it blow, and will there is a fire accident because of that, or it will just break down and there won't be any current supply in that? So what is the failure mode and what is its effect? We have seen in the step 3. Step 4, we are talking of the severity of the failure mode. Okay, so how severe it is? Is it too hazardous, or is the effect very moderate? Is the effect very light in nature? We are calculating the severity of the failure mode in terms of risk priority number. Okay, step 5, identify the cause of the failure mode. Cause. Okay, say there is a short supply. Okay, that is the failure mode. Why did it happen? What is the cause? Okay, the effect we have seen was it has failed. Okay, the failure mode was an effect. But what is the cause of that? Is it a manufacturing defect of the product, or is it the design defect? What? Why did it go wrong? What is the reason for the component to fail? We are finding out the causes of the failure mode. Causes. Okay. Step 6 is determine the probability of occurrence. Okay. So we are finding out the probability of occurrence. So how do you find out probability? If you must have studied in the science of probability, so we have different definitions of probability. Okay. So one of the definitions of probability says that it can be found out by the classical definition of probability. Classical definition of probability says number of times an event can occur divided by total number of cases. Okay. So here, based on the historical information, see, when there is a cricket match, I hope everybody watches cricket here. Okay, so when you watch the cricket match, before the match starts, they give you, like, suppose there is a match between India and Australia. Okay, they will give you the statistics. Like in the past, 1 year, so many matches have been played, and India has won so many matches, Australia has won so many matches. Okay, why do they give that? Because based on the historical information, we have certain tendency to predict the future also. Okay, so they give you the chances, rough chances of India winning the game. Okay, so they give you the previous statistics. Okay, so the that is what is done in finding out the probability of occurrence. Probability of occurrence is basically found out by historical information. Okay, but suppose there is no historical information available. Say one country is playing for the first time with the other country. Okay, then how is the probability figures given? Okay, in such cases, maybe the country A and B are playing the match. A has played matches against some other countries. B has played matches against some other countries. Okay, based on their individual performance, some personalistic or subjective probabilities can be assigned. See, we often say that there are 70% chances, 80% chances that something will happen. Okay, a particular event can happen. Okay, how do we assign the 70%, 80% cases? Okay, it is the subjective probability, subjective. So based on the expert's opinion, what we are doing is we are able to assign the probability values. Okay, so this is what we do in step 6. In step 6, we determine the probability of occurrence of a particular failure mode. What is the probability of occurrence? That is done in the step 6. Okay, then are all the steps clear so far? See, we have divided the asset into components. We have found out what are its functions, how many different ways it can fail. If it fails, what are the effects on people, product, and the property? Okay, then what we have done, we have found out the severity of the failure mode, and we have also found out the causes of the failure mode. Why is a particular failure mode caused? What is the real cause of it? And then we are trying to find out in the 6th step, for a particular cause to occur, what is the probability? Probability can found out from the historical information or from the personalistic subjective probability values can be assigned. Okay, then coming to the step 7. Step 7 is to do with the identify controls. Okay, so here what we do is, what are the controls which are already available to prevent or detect? Okay, there are some things which can't be detected. Okay, uh, or can't be prevented. Okay, for that at least detection. Okay, detection, right? See, earthquakes can be prevented. Okay, earthquakes happens, you really can't prevent, you really can't stop it from happening. Okay, but at least you can detect it. Okay, so while detecting, what will happen is the severity can be predicted before, and then some necessary action can be taken, at least some warning signals can be given. Okay, so here what are the controls which are available for prevent or detect the cause of the failure mode? So for preventing or for detecting that failure mode to happen, what are the control mechanism you have on place? Okay, you have to think about that. Okay, then already the control mechanism is in the place. Okay, so how effective it is been working, you have to find out that. Okay, in step 8, you are finding out the effectiveness of the current control mechanism. Okay, and based on the probability values affected, given to the causes, right? We have found out risk priority number. We have to prioritize in what ways we can uh, stop or we can predict the failure. Okay, and then based on the risk priority number, we have already ranked, we have prioritized the different uh, failures. Okay, and then next one is to take an action. Okay, take an action as to what we are going to do if this failure mode happens. How are we going to predict it? Okay, so these are the different steps in the FMEA. Okay, FMEA stands for failure modes and effects analysis. So what we are doing here is we are dividing the product into different components, the machine into different components, and what are the different components functions we are finding out, and then in different ways how differently it can fail, and what are the causes of that failure, what are the effects of the failure, how severe it is, and we are prioritizing, and we are also examining the control mechanism which is in place, and we are taking a necessary action. Okay, so this is all about the failure modes and effects analysis. Okay, is it clear? A very important topic, right? So here you
Excuse me,
can,
ma'am.
yes, sir.
Uh, may I know in reality where FMEA is used, ma'am? In what kind of industries or where it is used exactly?
FMEA can be used in all the industries, sir, for any of the assets, because assets have certain economic life, right? They have
Yes.
in the next few metrics which we are going to do, it will tell you more about the how frequently the machine is failing. Okay, so there are different mechanisms. This analysis talks about cause and effect analysis, causes of failure, and we are seeing the effects of failure, and we are taking a remedial action. Okay.
Ma'am, yeah, but yeah, doing FMEA for each of the equipment, it takes lot of time in the industry, no, ma'am. How can they manage
Sir,
this time? Yeah.
based on the artificial intelligence, we can find out it very easily, sir. Like we are based on the historical, we have something known as knowledge management, right? So we have known failure modes of the particular asset, okay, of a particular component based on the historical information. In the knowledge management, we store everything whatever has happened in the past, right? So based on the historical information, we can take the corrective action soon.
Okay. What if a product is a new one and they wanted to
So
do
here we have
FMEA?
given the FMEA applications in your course materials, sir. You can see here the Food and
Oh,
Drug Administration has recognized FMEA as a design verification method for drugs and medical devices. Hospitals also use FMEA to prevent the possibility of process errors and mistakes leading to incorrect surgery or medication administration errors. Okay, you can see here FMEA applications are also given in your course material. Okay, in aerospace, automobile industry, it finds application in various areas such as healthcare industry. With patient safety a priority in healthcare, the technique has seen application in healthcare. Okay, so these are the benefits of conducting FMEA. It can increase the customer satisfaction by improving safety and reliability and mitigating the adverse effects of problems. You can go through this. Okay, here we have this all is a again human diligence has to be used along with the control mechanism in place. Suppose some person is not diligently using the methods, then anything can go wrong. Okay, control mechanism has to be, because there are many stages where human intervention is there, right? So there, if someone says that this effect is not critical, then we really can't help it. Okay, so here probability of occurrence raise probabilities are found out: occasional failures, repeated failures, or relatively consistent failures. Based on the frequency of failures, we divide that as the we assign some probability values. Okay, so you can go through this, you can see the applications also. I'll also find out, sir, try to find out that, sir.
okay, madam. Okay.
Yes. Maybe in
Ma'am,
the first
one
class.
small, another
Yes, sir.
small, yeah, one doubt. Do we really have a FMEA softwares?
We have to discuss this with the IT professional only, sir. I'll
Oh,
talk to sir. I'll talk. We have an MOU with the technology business incubator. Maybe uh, I'll further find out about this technology, sir.
Okay,
Okay, if
madam.
there
Thank
is
you.
a software. Again, it depends on the domain knowledge, domain expertise of the industry, sir, because the assets or the machines whichever are used in different industries across the industries are different, right? So we should have the mechanism, as I've told you in the last maybe the couple of classes back, that our students were trying to find out software tool which can really find out when that machine is going to go for repairs. Okay, so they named it as a machine horoscope. Means it will tell you about like based on the metrics, the different mechanisms they wanted to find out when is the machine going for repairs. Okay, so uh, based on the working condition of the machine, we really can predict, sir. Okay, it depends from machine to machine. Okay,
Okay, madam.
yeah. Then we have certain other metrics which we'll quickly go through. Yeah, where is it? Yeah, MTTR. Yeah, MTTR is one thing. You can just go through this. What is the mean time to repair? Okay, MTTR is another important metric. Okay, so you can see the definition. Uh, It refers to the amount of time required to repair a system and restore it to full functionality. Okay. So MTTR is the mean time to repair. Okay. Whenever we call it as a mean time, it is the average of the times which is usually taken. Okay. So what is the mean time to repair? He has shown it in a diagram here. You can see here. Mean time to recover. Yeah. Failure occurs, the red spot, whatever you have seen, the initial point where the failure had occurred. So failure notification time, by the time you have notified that failure has happened, okay, in a particular asset, okay, then you're trying to diagnose the problem, what the problem is, okay. Then, sir, if this here, your FMEA can really help you out. So diagnosis and all, if you really have done your FMEA thoroughly, diagnosis will take lesser time here. Okay, because you know these are the different ways in which a product might fail. Okay, so diagnosis will take lesser time. Okay, so failure notification time, then diagnosis time, then really repair starts. Okay, and after repair starts and repair is getting over, then you test it again. Okay, you test it, then you return to the normal operating conditions. So the green point, wherever the distance between the time gap between the failure occurs, that is the red dot on the extreme left, to the resume of operations, this time is known as mean time to repair or mean time to recovery, a very important parameter. Okay, a very important parameter, because we always it's an opportunity loss. Our normal production gets comes to a standstill when a machine goes for a repair, isn't it? So we have to find out the mean time to repair or mean time to recovery. Okay, so this is the time gap between failure occurs to resuming of operations. Okay, so let us see the formula for MTTR. MTTR is equal to total maintenance time by total number of repairs. Okay, see, he has given you an example of a pump which has failed for 3 times over a span of 1 day. Okay, 3 times it has failed. The time spent repairing each of these breakdowns totals to 1 hour. Okay, together it has taken 1 hour. Means for once, maybe it was 10 minutes only. For once, it was taken 40 minutes. It can be different. Okay, so MTTR is total of 1 hour for how many repairs? 3 repairs. So 1 hour divided by 3, that is 20 minutes. Okay, so mean time to repair is simply total maintenance time divided by total number of repairs. Okay, so it can be found out for a day, it can be found out for a month, okay, or whatever span it is. Okay, suppose the repairs are not too often, we can find out. Yeah, uh, so mean time to repair is one important metric. Okay, then uh, next metric is mean time. between failures. Between failures means once the machine has failed, the next time it has failed. Okay. So how much time machine was in operation between that time? That is also an important metric. Okay. Mean time between failures. Mean time between failures. You can see here, mean time between failures. See, red spot on the left means failure occurs. Okay. There was a repair time. We got it repaired. Okay. Then we have resumed the operations, the green one. Then we were operating, and then again the machine has failed. Okay, so how much is the time between the first failure and the second failure? That is mean time between failures. Between failures. So how do you find out mean time between failures? Is total operation time by total number of failures. Total operation time by total number of failures. See here, for the extending with the same example he had taken, suppose in a day there are 10 hours. Okay, in a day, in a working day, there are 10 hours, and out of 10 hours, 1 hour has gone for this repair. Okay, 1 hour has gone for the 3 repairs. So how much of the time the machine was working? 9 hours, isn't it? 9 hours it was working, and in between 9 hours there were 3 times it went for repair. So 3 hours is the mean time between repairs. Okay, between failures. Okay, mean time between failures is total operational time, which is uh, the productive time divided by total number of failures. Okay, that is mean time between failures. Mean time between failures. Okay, these metrics are very important. Yeah, one more metric. This is, yeah, this metric. What is it? Yeah, mean time to failure. Mean time to failure is a very basic measure of reliability used for non-repairable systems. It represents the length of time that an item is expected to last in operation until it fails. Mean time to failure basically talks about the economic life of the device. Okay, lifespan of the device. So these three are very important metrics. Okay, MTBF is used only when referring to repairable items. MTTF is used to refer to non-repairable items. Mean time to failure is used for non-repairable items. That's what we are talking of, economic life of the asset. Okay, for the assets or for the components which are repairable, we talk of mean time between failures, because there is one failure, again the machine was in operation, again it has failed. Okay, so these are the important metrics. You can go through the case study in the last. So the questions which are asked here is, what is FMEA? I'll get back to your question, sir, again. Okay, I'll try to find out more on that, and we'll discuss about that in tomorrow's class.
Okay, ma'am.
Who was that? Can I know your name?
My name is Sri Harsha.
Sri Harsha. Okay, Sri Harsha. We'll get back to it in tomorrow's class. What you're working, is it?
Yeah, I'm working
Okay. In which industry you're working?
software industry.
Software industry. Okay,
I came across this FMEA in my industrial safety course.
uh-huh.
So I just thought of asking whether
Okay.
again, yeah, I
So
forgot. Yeah.
you have to give me the ideas, like how we can design a software for that, the programming part.
I'm not in programming, madam. It's okay.
Yeah. I mean,
I'll give my
I'll
best to
try
you.
to find out, sir. Okay.
Yeah.
So any doubts in today's class? So here we are talking about the different metrics. This is the method where we are analyzing the causes, effects of it, the severity of effects, and then taking a necessary action. And we are talking of different metrics like MTBF, MTTF, mean time to repair, mean time to mean time between failures. Any doubts?
Madam, once again, see,
Yes, sir.
do companies really have the time to do all this analysis, or they
They
do?
do have, sir. They do have, because you have see in the maybe the before class we were discussing, the people who are planning have to be segregated from people who are in operation. Okay, so you have people who really they need to have, because you have to abide by the safety things, and a few of the machines they can be hazardous. Okay, if they fail they can be hazardous, they can be having some injurious chemicals, or it can lead to the blast. They have to be very careful about that. Okay, and otherwise also the safety of the assets, you talk of the assets turnover, like how the assets have been effectively you converting into sales and all that. They do take care, sir, of all this.
That's all, madam. Thank you.
Okay. Any other doubt? Shall we resume to tomorrow's class then?
Okay, ma'am.
Okay then.
Thank you.
Thank you so much for your patient listening. Okay, we'll resume to tomorrow's class. Thank you.
Thank you.
ఎలా మాట్లాడితే అయిపోతుంది.